Namaskara, welcome to Tech Girl Kannada YouTube channel. Now, algorithm of DFS. The purpose of this is to obtain the sequence of jobs to be executed resulting in the topological order. And input is U and A. U is the form where the DFS traversal starts from, that is the source node. Now, n is the number of vertices in the graph, age adjacency matrix of the graph. Global variables that are S to know where the nodes visited and what are the nodes that are not visited. For that we use S array. J index variable to store the vertices only those nodes which are dead ends or those nodes whose nodes are completely explored. And resultant array which holds the order in which the vertices are popped. So output as res indicate the variable vertices that reverse order that are to be executed. Visits the vertex u, s of u is 1. The traverse then deeper into the graph till we get the dead end of that. All vertices are visited. Then if we take DFS of v comma n comma a, when we if a u and b, is there any direct path, and if it is not visited, then you have to go deeper into that part. J plus 1, this stores the dead end vertex which is completely explored, and rest of j is equals to u, that is finished. Then the topological sort begins. That will be of in the same way, initializing to indicate no vertex has been visited, and then from 0 to n minus 1 make everything as visited as 0, and then an index to be 0 till the s of u is 0. Call DFS of u comma n comma 0. Output of the topological sort will be printed here. Then for adjacency matrix calculation, since it will be from 0 to n minus 1, 2 loops are there, we will get theta of n square. Running time for an DFS is the time required to execute the statement. This statement n minus 1 minus 0 plus 1, it will be n taken outside, again n minus 1 minus 0, that is n square, theta of n square. N is nothing but the number of nodes or vertices. If there is a cycle that a topological sequence does not exist for the particular problem. Topological sort using source removal method. In this method, a vertex with no incoming edges is selected and deleted along with the outgoing edges. If there are several vertices with no incoming edges, arbitrarily a vertex is selected. The order in which the vertices are visited and deleted one by one results in the topological sorting. We were finding here 1 and 2 with no incoming edges. We shall take 1, delete 1. Then 2 is with no incoming edges. Then we will remove 2. Then we have 3 with no incoming edges. We will remove 3. 4 and 5 both doesn't have any incoming edges, we'll go with 4. And then 5. 1, 2, 3, and 4, 5 represents the task to be completed. 1, 2, 3, 4, 5 topological order, the order in which each task has been completed. Then DFS topological sort C2, C1 to C3, C4 to C5. For DFS, we have it like this. They have given another graph. That is given as in the picture. So from this graph, we have to write the adjacency matrix of A. If the edge is present, 1. If no edge, then 0. In degree of the each node. For 0, 0. For 1, it is 0. Sum of columns in degree of I gives you this. Then for DFS making, you will go to steps, initial steps. Then stack you will be having. U pop solution T. V equals to adjacent of U and in degree of jobs. Job assignment problem. We have 0, 1 as the in degree 0 stack. Then for you will be popping 1. Solution T will be 1 with what it is. Solution T will be just the popped element together 1. Then for V, it is the adjacency of U. What are the adjacent nodes for 1? It is 3 and 4. We have 3 and 4. And then if we remove 1, for 3 and 4 it reduces by 1 in degree. So then again next if we go, for 4 also we will not be having anything. So we will take 4. Then solution T is 1, 4. Then 5 is the adjacent. You will reduce one number from 5. Then next pop 4. Pop 4 is already happened and there is nothing here. And stack above the stack, on the top of the stack there is only one element left, that is 0. For 0 we have 1, 4, 0 as its adjacent, 2, 3 as its adjacent, 1, 4, 0 is its solution. Then for 2 and 3 we will reduce the in degrees by 1. Then next we'll take 2 on top of the stack. 2 is removed. For 2, 3 and 5 are the adjacent. Reduce it by one number. Then for 5, then for 3 it is 3 only. 5 is the adjacent, that is also reduced by 1. Then 5, 5, 1, 4, 0, 2, 3, 5. That is the topological sequence. Find the vertices whose in degree is 0 and then place them in the stack. That is what we have done. These vertices denote the jobs which do not depend on any other jobs and that should be performed independently. Pop a vertex u and it is task to be done. Add the vertex u to the solution vector. This vertex represents the Next job to be considered. Considered for executing. Find the vertices V adjacent to the vertex U. The vertices V represents the job which depend on job U. Decrement in degree of V by 1, thereby reducing no dependencies on V by 1. Since in degree of V gives you the number of jobs to be completed. Before job V and job U is completed, the independent jobs of V are reduced by 1. This is the topological sorting. ANS finding in degree and topological sorting and stack. The same thing here they have written. While scheduling task graphs in the distribution, similarly, it is usually needed to sort the tasks topologically and then assign them to resources. In document management, similarly, each document on this system has some kind of precedence constraint to set of other documents, content type, field replacing, then the system should be able to generate an order of documents with a preserved topological order. Analysis of topological sort using ALL is an array. This is linked list. All the vertices are represented. Vertices they become indexed into adjacency linked. So it is big O of V plus E. Total number of edges is E. N is V. V plus E big O of V plus E. Insertion sort. In this arrange is the numbers in ascending order already done using the bubble sort. The list is divided into two parts, sorted and unsorted. As each item is inserted towards the sorted left part, the boundary moves to the right, decreasing the unsorted list. Once the boundary moves to the extreme right position, the elements towards the left of the boundary represents the sorted list. Consider an array of n elements like this. I equals to 1 to n minus 1. Item equals to a of I, where I equals to 1 to n minus 1. 1 to 4. That goes like this. Sort the list in ascending order. A is the list of sorted. Total number of elements in the list for I to n minus 1 item should be a of I, then j equals to I minus 1. That is the preceding element, while j greater than or equals to 0 and item less than a of j plus 1 is equals to a of j is j minus 1. And while a of j plus 1 item and for given list contains some multiple items with the same value, after sorting even through the position of the multiple times, they appear in the order as they appear in the given list, so it is stable. Other than that, input array or all other array or another extra space is used during sorting, so is in place. In other algorithms these extra spaces are used, but here we don't use, so it is in place. Analysis. We see time efficiency will be best case time efficiency. It is already sorted. Whenever for a loop is executed, the conditional expression is item less than a of j is executed. So at that time you will have big omega of n. Worst case time efficiency occurs when conditional expression is executed. Maximum number of times occurs when every element of the list are sorted in descending order. So at that time you have to proceed with this. Y equals to 1 to n minus 1, j is equals to 0 to I minus 1, then I n into n minus 1 by 2 n square by 2 minus n by 2, that is equal to big O of n square, theta of n square. To insert an element item x with the index I is at the correct position, the total number of times the while loop is executed is I plus 1 by 2, I plus 1 by 2. That is theta of n square. Binary tree traversal and related properties. A binary tree is a directed tree in which out degree of each node is less than or equal to 2. If any node has more than 2 subtree, then it is not a binary tree. Then binary tree itself divides a binary tree into two subsets of the same type, namely left subtree and the right subtree. So many problems on the binary tree can be solved using divide and conquer. So various operations are tree traversals, height of the tree, number of nodes in the binary tree, number of leaf nodes in the binary tree, traversing methods of visiting each node of the tree exactly once in a systematic manner. Various traversals are there: pre-order, in-order, post-order, node left, right, left, node, right, like that. Then to find the height of the tree can be obtained by finding the max of the height of the left subtree and the right subtree and adding 1 to it. Is defined as the length of longest path from root node. Height of tree, if tree equal to null, return 0. Return 1 plus max of height of TL, comma height of TR. Number of nodes in the tree. The number of nodes in the tree obtained by traversing the tree in any of the traversal technique and increment the counter whenever a node is visited. If t equal to null, then return count node of TL, count equals to count plus 1, count node of TR. So number of leaves in the tree. The number of leaves in the tree is obtained by traversing the tree in any of the traversal technique and then counting the number of nodes if and only if the node is visited has empty leaf and empty left and right shells. Count leaf t equal to null and then return count leaf of TL, TL equal to null, then TR equal to null, then count equals to count plus and if count leaf of TR. Thank you for watching. Do like, share and subscribe to my channel.